Okay.
Okay, so good afternoon to everybody attending this seminar. This is the 7th webinar of FEUP Prime Talk series on engineering and innovation. And these seminars are intended to strengthen the relationship between academia and companies and contribute to the discussion of relevant topics for the sustainable development and society's challenges. So it's an honor to moderate this webinar. This has been a role that has been taken by FEUP's Dean, Professor João Falcão e Cunha, that is here with us today. And in previous editions of these seminars, I'm therefore replacing someone that we very much care for the role, an important role on this innovation series and FEUP Prime Talks. And it's also because it's a very privilege to be able to interact with our distinguished speakers for today's seminar, Wolf and Jaime, whom I thank, of course, and I very much will appreciate listening to their contributions, their comments, their presentations, and I will pass into the presentation of their short video. So thank you very much for accepting our invitation to participate in this webinar, and I also thank you on behalf of FEUP's Dean, Professor João Falcão e Cunha. So I would proceed with the introduction of our two guests. So Wolf Merkel is our keynote speaker, is a member of the board of directors of the German Technical and Scientific Association of Gas and Water, with responsibility for the water department. He graduated as an engineer in the field of process engineering with a specialization on water chemistry and received a PhD degree in industrial water treatment. Starting from 1998, Wolf worked as a process engineer for water treatment at the Rheinisch-Westphalian Institute for Water Research. And since 2002, he was nominated as technical director of IWW. Under his direction, this institute has built up additional competencies in the field of water networks, as well as water economics. And in the last decade, the Institute has successfully promoted the European expansion of IWW research with important topics on including climate change and digital transformation of water supply industry. So Wolf, thank you very much for accepting our invitation. It's a pleasure to have you with us.
My pleasure, yeah.
And Discussant that will follow today's webinar, the second part, is Engineer Jaime Gabriel Silva, Chief Innovation Officer at Águas Douro e Paiva. He has been member of the board of different companies of Águas Portugal Group, including Águas Santo André, Águas Centro Litoral, and AdDP Energia. And he's also invited professor at the Instituto Superior de Engenharia do Porto from the Polytechnic Institute of Porto. Thank you very much, Jaime, for joining us and for your contributions to these discussions. So, as you know, the topic of today's discussion is rethinking treatment with asset management for water systems. This webinar will be divided in 3 parts, with the first main presentation by Wolf Merkel, and then a second part with the comments and discussion led by Jaime Silva. And finally, in the last part, that is open to everyone in the audience, including those in Zoom, as well as those attending the broadcast in FEUP TV channel. So I asked the attendees via FEUP channel to use the chat tool to ask questions, and they will be placed also to our invitees here in the Zoom session. So I think we're ready to start. So I thank again Wolf for accepting our invitation to participate in the FEUP Prime Talk webinar. It's a pleasure to have you with us. It's a great opportunity to listen to your views on this important topic of asset management in the water industry. So thank you, the floor is yours.
Yeah, Anna, thanks a lot. And I would directly start with the presentation here. The topic has been presented. It's rethinking treatment with asset management, and I will shortly come to this point. Why rethinking? Why I think it's a good opportunity to really start thinking about asset management, and not only in the linear way, but really rethinking the whole system. My employer has been already introduced. It's a member-driven association in Germany with the main topics on standardization, on research development, on testing and certification, and vocational training. And the rest is also important, but I leave it due to the time constraints. Also mentioned is that DVGW has own research facility, including the TZW in Karlsruhe and IWW in Mülheim. So, and now I'm in the middle of the change in the water cycle, which is quite obvious for all the experts listening. It's due to climate change, to economy and demographic changes. We have a development of technologies, digitalization, of course, is a main driver, but also we have in the society, in politics, and in the public growing awareness for the importance for water and why it is so important to take care of these elements. The other aspect, and this is also the point which brings us to the part of asset management, is the aging infrastructure. And these summary of different drivers from the change provides challenges and opportunities for the water infrastructure. And I would like to illustrate this in the following presentation. When we talk about a regular asset life cycle, we also know that there are quite a number of influences which shape this life cycle, which are normal procedures in terms of degradation, which are procedures which come from the evolution of technologies, of the circumstances of drivers outside, and in the other direction, which comes from disruption. When we talk about disruptive elements like degrading raw water quality, conflicting water demands, demographic change, or new quality targets, it could be that the thoroughly planned infrastructure will reach its asset life end in an earlier stage than planned. And I would like to explore these different evolutions in the following part of the presentation by exploring it in terms of a number of case studies. Case studies, the whole are 7. Here are 4 and 5 are in more pale color. The reason is they come from the sewage topics, and if there is further interest, I could provide slides and more information on that, but now I will concentrate on the drinking water part. What is described here in asset life cycle under change condition is in terms of change in the water cycle, change in the technology, change in boundary condition and legislation. And I would like to explore all these topics now in form of the mentioned case studies. I will start with case study 1. All case studies are provided from recent development or planning exercises from Germany. In most of the cases, I try to give some sort of a geographic orientation for all these aspects. This one, for example, is from the far west in Germany. Here are the borders to France and to Luxembourg. The area is the Saarland and the neighboring federal state. What you can see here is a low-range mountain valley with, in the original state, 8 decentralized supply systems with 250,000 inhabitants. You can see this here in this graph. These are the transport connection lines in the blue dots. There are several water reservoirs. And the actual situation is like this. We have quite a number of decentralized supply systems somewhere up in the mountains. You can see the slope of the mountains is basically in this direction. And for one of the major parts of the water supply comes from the river Moselle down here. The implication is when it comes from the river Moselle, it has to be pumped upwards. And so we have to provide a lot of energy here for this first step. These decentralized systems provide the water for this or for another valley. They were not connected in the original state. The external drivers which came to this aspect of replanning or rethinking the whole system was the aging infrastructure on a whole. That means treatment plants, wells, distribution were in a state where reinvestments were needed. The next aspect is energy efficiency requirements, and the third is resilience for drought and flooding events which occur more frequently in the recent years. So the infrastructure options were a case-by-case renewal, so each of the system renewed by itself, or a new system approach. And the new systems approach looks like the following. What has been established is that we make use of the basic slope we have here, starting from this mountain area and using the water provided from a reservoir which provides a water amount of 1 million cubic meter per year. And the second part of the idea is to connect all the downstream systems into one system. That means the main part of the 1 million water which is needed here comes from above and is then flowing downwards down to the last supply area we have in there, which means that we save the energy which is required from pumping up the water from the Moselle area, and we have also the opportunity for energy recovery throughout the whole slope in different installations. That means there's, of course, quite a number of restoration renewal work, but the overall system at the end is much more energy sufficient, and it's also much more proof for flooding events or whatever. There were also additional benefits generated from parallel construction of gas and biogas gas pipelines and glass fiber lines, and all this contributed to the overall financial revenues which were generated in the system. You see here the figures of the total investment, including subsidies and loans, and the astonishing part is that the business case was positive after 5 years. So really, I think an engineering approach which made use of all the knowledge we had from the systems. And of course, there were quite a number of aspects which were relevant in terms of asset management, which are summarized in these slides. The asset management part is that we needed a technical evaluation of all the assets available and an estimation of the asset value. The reason for that was that the asset value was transferred with capital to shares in a joint enterprise, which was then formed based on the original enterprises on the landscape. And for that reason, we needed technical and also economical estimation of all the assets. There are much more details on that, but well, I think the case in this case is illustrated for now. I would like to move on to the cases 2 and 3, which is also a mountain range area in the northern part of Germany. You see here the shape of Germany. It's in the northern part. It's the provision of water supply to the metropolitan area of Bremen, which is situated at the coast, and the larger amount of the water supply comes from a mountain area, which is about like 300 kilometers far from that area, middle range mountain area called Harz. There's an operator here, which is the Harzwasserwerke written in here, which provides water via a system of 520 kilometers of transport lines, and also operates a number of water treatment plants on the way, which also contribute to the overall amount of the water, which is then transferred into this metropolitan area. What were the drivers for the aspects we're talking about? In case 2, we will talk about degrading raw water quality, and in case 3, the aspect of rethinking the overall function of the system. For the case 2, there were the background and main issues for consideration were several, where in terms of climate change, in terms of extensive drought monitoring in the last years. You see here the results from the groundwater level monitoring in past years, and obviously the red parts are much lower than the historical standards, so posing a problem for groundwater exploitation. The second part of the aspects is demand, increasing demands in metropolitan areas. The third part of the drivers is increasing nitrate loads from farming, which puts pressure on the quality of the groundwater. And the last part is that the assets, which stem mainly from 1930s to 1970s, need renewal and need expansion in terms of the higher need up north. So in case 2, we would like to look a little bit closer to the aspect of increasing nitrate loads and renewal options for that supply area. This is one of the groundwater area for one of the groundwater treatment plants, and you can see here the wells and the measuring results for nitrate, and the indicators show that in the western part the nitrate levels are rising from year to year. Here in the left part, above 50 milligrams per liter, above the limiting value, and in the eastern part in an increasing wear. So we have external drivers, which means we have rising water demand for supply and irrigation, and we have climate change, which is always putting a problem, increasing pressure on the system. In all these areas, we have increasing nitrate concentrations, and we show that the denitrification potential in the ground is diminishing. So what are the options which were one after the other really explored by the operator? The short term is to change the changes in the extraction regime to make use of the different concentration levels we have here. So take more part from the eastern, so we have higher shares there and reduce the nitrate concentration. The medium part is to explore new well sites with lower concentrations and to start planning on reverse osmosis treatment. Technically, it's feasible, uses a lot of energy, but one of the crucial aspects which is unresolved is the concentrate discharge for these kind of installation. The long run is, of course, on water protection, on the reduction of the agricultural impact. This is the only sustainable solution for this aspect. So what is involved in terms of asset management? All the existing wells have to be evaluated. The groundwater system has to be reviewed with the system data, and modeling has to take place, and then asset evaluation is important for driving all these solutions in the right direction. In case 3, we're talking about rethinking the whole system. The Harzwasserwerke, as I introduced in the beginning, have a multifunctional system approach, and the solutions for this change and the drivers, they lie in different dimensions, which is in use management, in resource management, in asset operation and asset management. There are a number of measures which are described for each of the sectors I introduced. I would concentrate of the aspect of asset operation, and we'll introduce one of the ideas which were followed by the operator. A classical approach of bulk water supply is you take water from one central part for a reservoir, for example, and then distribute it over your transport grid to the direct suppliers, which distribute it then in their municipalities and villages. And the new idea the operator is exploring right now, but in the beginning of exploring, is to use this distribution network in terms of a distribution platform for input and for output volumes. That means that the direct suppliers, which were from in the original part supplied by the bulk water and have their own resources, they have also the potential to provide input water into the system. So you use this as a kind of a backbone for distributing water in the whole area and make use of the different climate and weather conditions you have in a certain region. So this is rethinking the whole system. Of course, it has several implications on the asset management part. So far for the case 3. The cases 4 and 5 with the aspects of wastewater, I will skip here. They as an example for energy neutrality for a large wastewater treatment plant and downsizing capacities in a certain circumstance by using a new technology. But I would like to move on to the case 6, multi-effects of climate change, resilience needs in the case study of the Bodensee Wasserversorgung. Bodensee is the Lake Constance in the southern part of Germany. Here again, southern part of Germany, the Lake Constance is here close to the border of Switzerland and Austria. As you can see here from the diagram, the water from the Lake Constance is pumped over 200 kilometers and provides water to the metropolitan region of Stuttgart and of course to the neighboring cities. It is a yearly supply of 130 million cubic meter for 4 million inhabitants. The Bodensee Wasserversorgung is a public entity which is owned by the municipal members. They have a large pipe network and they have one water treatment plant with a classical surface water treatment scheme, microsieve, ozonation, filtration, and disinfection. What are the pressures and drivers for this company? Climate change makes the lake fluctuate in level. There are increasing peak demands, and there is an invasive species, the quagga mussel, which has their larvae entering the water treatment plant, so that there is filter clogging, and the cleansing efforts are increasing from year to year. We have pressure on the raw water quality, as in most of the surface waters, vulnerability for contamination at the single inlet point. I come to that in a minute. And the asset life for many of the components is at the technical limit. So it's time to rethink the whole system. What is the approach the company has taken? The new concept means to install 2 separate lines with a pre-ultrafiltration. This pre-ultrafiltration is mainly to keep the mussel larvae out of the system. What you can see here is the picture. The water treatment plant is here on the top of the mountain, like about 300 meters above sea level. This is due to the fact that the city of Stuttgart, where the water is supplied, is also more or less in this range, so it makes sense to make use of this altitude. And you can see here on figure 1, this is the existing single inlet point, and this will be doubled by a second inlet point in the future. And this is then the whole system, which how it would look like in the future. So 2 inlet points with 2 separate ultrafiltration lines. Before the water treatment plant, and of course this is a large-scale project with installation of the pipes, of providing electricity in this area, and overall you have to ask quite a number of people with stakeholder participation. You need several permits in terms of conservation, protection, and heritage of the whole area. The overall invest will be several hundred million euros, and well, there's an estimated raise of the water tariffs. This is more or less the project as it will develop. This will last from now on to the year 2036. So it's really some sort of like half of a generation project for this renewal. Yeah, the last example I would like to introduce is more interesting in terms of the approach follows. That means we have a planning objective of the new waterworks, design criteria were specified, but there was a planning exercise for this waterworks which had not really lead to the optimal results. And the alternative approach, which has then been followed by the operator, was that they installed a function-based design process following the framework of value management. And I think this is interesting enough so that I provided the European standard on that. The basic idea is that you develop alternative options for solving this the design problem in terms of different solutions, and then consult a panel of experts, like about 10 to 15, and ask them for their evaluation of advice. Of course, you have to plan in a certain way, you have to make cost estimations, but by this means you're looking closer to solutions and you look to different approaches of finding the optimal way. In short, the result was that the concept was developed in a more cost-effective alternative, saved approximately 2.5 million euros as compared to the original design. And well, not important the results, but I think the approach is important for maybe for a closer look. Yeah, and then I'm short for the summary. I tried to introduce the different cases in terms of what are the aspects of asset lives and why it's time to rethink the whole system. What are the answers, responses we have available for that? They start from replacement, from installing next generation technology, from capacity adjustment to provide additional functions if needed, to the aspects of higher resilience, and up to the point of rethinking the whole system concept. I try to illustrate some of the examples by using these case studies. The data requirements are quite heavy in this aspect. You have to look for asset data, for the consumption, for systems data. You need forecasts for several parameters. And of course, in most of the cases, some trials beforehand are advisable to go in the right direction. And of course, we need an economical evaluation. Yeah, let me finish this short and fast overview with rethinking treatment. The idea is the future asset is likely above the cloud, so you have to take some steps to see it. Thank you for your attention.
Thank you, Wolf. Thank you very much for your very interesting and comprehensive presentation on the challenges and different solutions for these very relevant case studies. So we can now move on to the second part of the webinar. That will be a discussion led by Jaime Silva. And we are looking forward for your views, Jaime, on the discussion of these topics of asset management and the eventual confrontation of the Portuguese reality with the German reality, and the presentation that we have just listened. So it's a pleasure to have you with us today, and the floor is yours. Thank you.
Okay, thank you very much. Wolf, thank you for your very interesting presentation. I was particularly attracted by your scheme that you presented in the beginning and at the end of the presentation, where you put the asset management in the center of your analysis, and you have mapped. You were mapping the different possible circumstances that the assets can face, even during the life cycle, because it highlights two situations. On one hand, the regular life cycle of the assets, and on the other hand, the life cycle of the assets and their changes. And at the same time, your interpretation crosses the way that the assets can become old with different main types of changes. You refer the issues like legislation and technology or boundary conditions, and I think this mapping exercise depicts comprehensively a large set of situations that in asset management we must continuously look up for, and it is very interesting in my opinion. So in fact, at this moment, this puts many different issues crossing my mind, and I would like to start to put you one question related with changes. As we saw, changes are increasing fast, and the impact on assets life cycle is strong. But when we hear people talking about changes, generally it is about climate changes. Of course, climate changes have a key role in the water industry and in everything. But it was interesting that you mentioned several types of changes, not only climate changes. And you refer the demographic changes or the water consumption evolution, etc. Why is it important to underline these distinguishing types of changes? Some may have opposite effects, perhaps. How to predict the impact of exogenous conditions on assets? And more specifically, I'd like to ask if it is possible to anticipate the magnitude of the impacts and assess the risks. What is your opinion about that?
Yeah. Well, I'm convinced that when you start this this planning exercise in terms of rethinking a whole system, then you have to look at all the changing factors you have in your environment. We know that when we're planning assets today and we're constructing them in the next years, for most of the assets we talk about a lifetime of like 50, well, start with 20, 30 years for a treatment plant, like 50 to 100 years for a distribution network, and like 100 to 150 years when we talk about reservoirs. So it is really of utmost importance. I'm really deeply convinced that we have to look at all the factors which are changing the function and the potential lifespan of the system we're planning. And the most important aspect is, as I mentioned, climate, economy, and demography. Of course, there are some of the related aspects, but when people talk a lot about climate change today, this is also because it's more or less, it puts a sort of a focus of all the changing situations we observe for quite a number of years in the environment. But now it's in a sort of being highlighted by this aspect of climate change. What we usually advise for operators is that they try to figure out the best of knowledge in all these aspects. That means climate change studies with a forecast of the precipitation pattern in the future. We just finished one exercise with a 70 parallel scenario analysis up to the year 2100 for the part of Germany, for the economic changes, and for also the demographic and structural changes for the cities, the villages and the metropolitan areas. For all this sort of prognosis studies are available, and if not, I think it's a good advice to really dig deeper into before you start planning on data which more or less result from the past.
Another question is that from your presentation, I would say that asset management is more and more needed for the sustainable management of the infrastructures, ensuring resilience and adequate service levels at a fair cost. I like to think about asset management that way. And also the pace of change is increasing, and asset management tools and techniques may need to be refined, perhaps. What do you think and what suggestions, could you share with us about the asset management tools that will emerge in the future, or that you think that will be emerging in the future, or what will be the most critical techniques or dimensions of this topic?
Okay, maybe my answer is a little bit disappointing. I would say the tools are, for me, are of secondary importance. The most important is that we need data on all the assets we have, and with what technology we're processing the data afterwards. If we using like fancy equipment like artificial intelligence or planning devices in a sophisticated way, is less important than to really make clear that the data on which we're operating are of the best available quality, in order to bring this quality in the whole process of planning.
Well, just let me say to you that forgive me to interrupt, but to the data, to have the best possible data at each moment, it can be also a tool, and it involves also techniques. So when you say, I agree with you, what you have said, but simply the tools and the techniques must begin before sometimes. That's what you were saying.
Yeah. Yeah, that's the most important part. And as you maybe remember, in the first case study, I had one of the sentences which was like the data availability for all these systems was poor, but the data quality was even poorer. Yeah. And well, this is the case, I think, for many of the installations we'll look at. And well, it costs a lot of time, and it leads to some misinterpretation, some additional efforts before you really can start the work. So I could really, I would concentrate on to bring the data available, not on every single point. It must be with a certain wisdom and expectation. Of course, you cannot be prepared for every consideration, but the basic asset data on the state, on the lifetime, on the actual, on the life prognosis, and on the function of the system must be available. Otherwise, well, it's planning in the dark.
I understand. I also think that you have said something very, very important. It is important to have good data. It is important that we bring the data to a plan where we can have the best data available, and have some some capacity to predict future data. But I also think that if you're going to bring all this data and put all this data in a correct way, you also may need to know what to dig, where to dig, because so it is sometimes important also to have a glimpse or an idea on the tools that we can use after that with the data, because if we don't know, maybe we are collecting lots of data during years and years, and we are never getting a good solution. So my third question was thinking about that. Is digitalization an important topic? And what about the role of mathematics and statistics and artificial intelligence to support the best possible use of digitalization in the water industry? Don't we need to reinforce the relationship between operations and those areas of knowledge to monitor achievements, to anticipate problems, and select the best managerial actions given the limited resources that we have? When we seek for digital transformation, are we aware that algorithms involves lots of mathematical skills, and the data that we were discussing before, if we don't know how is it going to be used, are we collecting the good data? It's my question. What do you think, Wolf?
Yeah, I'm convinced that we're we could, or we should rely on the support of the new technology opportunities we have. That means artificial intelligence, big data analysis, and all that. And of course, there is an increasing need for developing like the relevant models. And with the relevant models, you can also specify the data needs. By this means, also concentrate your efforts on the top priority data with in distinguishing from the second or third rate important data. So all these tools help to identify the data needs and to specify them, because this is for sure. Data collection also costs a lot of effort and a lot of money. And I completely agree with piling up data which nobody really needs at the end is a waste of money as well. And it also hinders to get a clear picture at the end. But well, I would like to come back to the start of my answer, which is I'm convinced that for a number of ideas which are out of the box, out of the range from normal thinking, we cannot rely on the machines totally. So we need the engineers, we need the engineers with the innovative ideas. And I try to collect some of the ideas which, from my consideration, are not coming out of a regular data analysis, but need something like a innovative idea, a new approach, and a different view on the problem, which has been looked at like for decades before. But most of the approaches are out of the usual range, and I don't see, I would not rely on machine or artificial intelligence to provide solutions just from, well, combining data, millions of data, and say, well, this is the result now. I think this can also be proved from these kind of examples, yeah, and try to illustrate that.
I think I fully agree with you, because I think that ultimately when we are collecting data and discussing the data, if it is good or not, if it is correct, or if we need to have better data, at the end of the day, in fact, it is good because people are more aware of the system they are running, the system they are operating. And in fact, after collecting all that data and using digitalization, which is necessary, of course, and it is good to give some ideas and some ways to proceed. But at the end, we must have some kind of discussion with open-minded between technicians, operators, people, professionals from the sector, and that's the way that certainly we are going to find the best solutions, not directly via computer. That's quite sure.
Yep.
In case one, it seems that energy was maybe the key driver of the replacement solution that you presented. And I would like to ask you, this new systems approach, it's a question of energy, basically from what I have understood. In fact, that situation, that solution was there available for a long time, because energy didn't become expensive recently. So which was the decision process that led to the new solution, and why not earlier?
I think the main obstacle actually was that that responsibility for the systems was attributed to different municipalities. Yeah. So it's more an issue of well, we look at our own system, we think inside our own box, and we would not like to share some of the resources or distribute resources from our area with the neighbors. I think this is the main obstacle in the past. Of course, there are, because it's a middle range mountain area, there are some technical solutions which might not have been available or not at this price or this reliability in the past. But the main obstacle, I think, is governmental driven to overcome these governmental obstacles. I think this was the main point.
Yeah.
And one of the, just to add this, I think one of the really innovative ideas was not on technology, but also on building a joint interest from this case. So making the municipalities benefit from these new solutions, and by this means you reach much more acceptance and trust for this overall system. And I think this was one of the key factors for the success.
I think in our country we have situations like that also, and I think it's all over the world. Sometimes we have to solve a problem that is not a technical problem. It's also a politic problem, of course, a problem of relation between enterprises or between municipalities, and this is a problem of relation between people. So the human being sometimes is difficult to solve his problem.
Yeah, good to hear that Portuguese are not different from German then.
No. At least in that situation. In case 6, I could see that it shows how climate changes can motivate investments, and the investments were done or designed to obtain systems resilience, which is very important nowadays, and we discuss it a lot usually. But I could see also that the average tariffs were 2.2 euros per cubic meter, as you said, and the project predicts they will increase 0.25 euros per cubic meter, meaning rising more than 11%, more or less. Can you tell us how do populations see such growing in tariffs? And if it is a problem with the population, I don't know if in Germany those costs are a problem or not. In Portugal, they would certainly be. How do you face this problem with the population?
This was one of the aspects I mentioned in the very first slide I presented. We recognize that the importance of a reliable water supply is increasing in politics and in the public awareness. And this is the main aspect which is important here. When you explain a program like this to the citizens in terms of what is the benefit and why is there the need for this significant investment, then you have a good chance to really find the backup and the support of the population. This is one aspect. So it is accepted by the people because from a rational point of view, they can follow this kind of argumentation. The second part is that, as I mentioned, the water supply, this distribution and treatment system is more or less, it's owned by the municipalities, which is also owned by the citizens in a transferred way. And that means the citizens are more or less a part of the solution, and they see that there is an investment which also is an investment in their future, in the future of their houses, in their municipalities. And by this means you have not only to transport this raise in prices, but also can spread the word in this aspect that you can say, well, this saves your investment in your own property, for example. It makes your place livable also for the future, maybe for your own kids or the next generation. And by this means, you can really explain this part of tariff raising, which from my point of view actually is also a part, as we're talking about now, a 15-year period in this. So I don't think that these 20%, this 11% are really an obstacle on the long run.
Okay.
Yeah.
Okay. That's more communication. In case 7, you said a functional-based design process was followed, applying the framework of value management. and not a traditional planning process. Considering this case, but also the others that you presented, do you think that engineering schools should introduce new approaches in their teaching curricula? What's your opinion?
Yeah, I would support that, because it's a different approach in a way that you're not talking about, well, how I could solve a certain problem, but to find a couple of alternative solutions and really put them to the test in terms of their technical feasibility, in terms of their economical value, and in terms of their contribution to the overall solution. And I think this is a very systematic planning approach, which is helpful also for next generation of engineers.
Mm-hmm. I feel the same. I completely agree with you. And I would like to ask you also another thing. In case 2, you showed an inventory with around 1,600 assets, including several dams and water treatment plants.
Yeah.
For the options that were studied, this level of breakdown is certainly adequate, because they are big decisions that will last for decades. But is this the level of breakdown usually available, or do you deal with a more detailed breakdown of assets for evaluating less great scale decisions? I mean, do you use more detailed information to assess, for example, the replacement of some pumps, or you feel that this less detailed inventory is enough?
No, not at all.
Okay.
No, not at all. No. When you talk about 76 dams, I have also to add that this is actually an historical site from mining industry. So there are very small ponds and dams all over distributed there. So in terms of water supply from these 76 dams are 4 or 5 which are of importance, but the whole system is built as such. But of course, for each of these dams, for each of the treatment plants, for each of the pipes or the pumping stations, you need a really detailed inventory of the equipment, of the installation, of the construction, in order to make the decisions ready for the different operations you have to perform at a certain place. And not all the decisions are big decisions like the things I presented. Most of the aspects are quite simple, like to renew a pump in terms of higher energy efficiency. But well, this goes on the investment budget and has to return the money in a certain period of time. And so we need the information on the state and the optimization alternatives, for example. And this is on a much more detailed level than the list I provided here.
Yeah, because it's normally a problem that we face is we need to have more detailed information that we have in certain situations, some infrastructures, and we feel that sometimes it is very hard. We don't have all the people available that we have, and other things sometimes are not enough, and we must dig more to have a better capacity to take decisions, to make decisions.
Yeah, that's very important.
I don't know if there's time for another question.
I would probably open now to the discussion, because we're reaching the end of the time for this seminar. So thank you very much, Wolf and Jaime, for this high-level discussion. So if there are any questions in the FEUP YouTube, please write them in the chat. In here in the Zoom, the colleagues that are inside, can you please proceed if there are any questions that you would like to make?
Good afternoon, and thank you again for your presence. I have a question about the networks you're using, and whether cyber attacks are a possibility or are relevant in the water industry. It's not exactly on the theme, but it's a question that I thought about.
Yeah, it's a highly relevant aspect, and we really have to take care of the security in terms of cyber attacks and protection against these unwanted access from people from outside. We have some cases there, and I know from quite a number of German suppliers that they're investing a lot in these kind of cyber security plans, risk management in these terms, which means that this is not only on technology, but it's also on processes and on awareness at the staff level. It must be more dominant for every decision the people are making, and I think it's a really high relevant threat we are facing.
Thank you.
Mm.
Thank you, João. Any other questions? At the moment, there are no questions from the YouTube channel either. I would also like to ask one question, if I may, on the relationship between the companies and academia in the water sector. How do you see that will be the future in terms of eventually some topics that will be left for academia, how the relationship should evolve? Do you think this would be a project-based issue or a technical issue, or some of the needs for the future will be technically addressed at universities and then passed into water companies?
I can speak on behalf of my association now, because we really think that this part of bringing academia and the companies together is one of the key drivers for innovations. What we know from the past actually is that there has been quite a number of examples for successful collaboration addressing a certain topic, providing research contracts with a certain department, solving the problem, and well, this works sometimes better and sometimes less, but usually this was on a project-to-project basis. But what we really recommend for the companies is really to invest in a continuous relationship, which is, I think, beneficial for both sides, which means that the company, when they have a permanent access to ongoing innovations, they have a higher awareness of new and innovative approaches. This long-term collaboration helps the departments to focus on different issues, which are then usually more closer to the needs of the company, because you have a deeper knowledge of each other, and you can direct your research program also in terms of what is beneficial for the company. And the third part is with regard to staff, you get really higher flexibility and some sort of a mixing of academic and the company people. Maybe there are some changes. One comes to changes sites for a certain period of time and then returns, and this also strengthens the relationship. So I would really advise every company and also every department to really get in close contacts and try to build these kind of innovation alliances, or you might call it as you wish, but it's really a very good idea and very prospective.
Thank you very much. I would also like to take the opportunity to thank Engenheiro Vítor Dias that is here with us for the support for the FEUP Prime partnership since the beginning. I hope we in the future will have many opportunities of research collaborations in this water sector and on this topic of asset management and others. Thank you. Mm-hmm. I think that maybe we are reaching the end. Mm-hmm. So I think it's now time to close the webinar. I do hope that you have enjoyed as much as I did this discussion. It was a great opportunity to enlarge our vision on current trends and future directions in this field of asset management. And this certainly allowed us to consider the future opportunities of development in this sector, as well as this connection between the academia and companies in the water sector. So thank you again, Wolf, Jaime, all attendees, for the time dedicated to this webinar, for the sharing of your knowledge and of your thoughts. It has been really enriching for all of us. So thank you. Keep well. Look forward to seeing you again in future webinars and in other occasions.
Okay.
Thank you.
Yeah. Thanks a lot for inviting me. I enjoyed it. Take care. Bye-bye.
Thank you.